Okay, section 6.2, we really don't have a lot left. We have a quiz on this algebra, calculus basic skills practice. That's on Friday. If you do well on it, then it's the only time you're going to be quizzed on it. If you don't do well on it, we come back and hit on it again. The questions will come directly from this packet. So if you've done on problems and the answers are online, you should be in good shape. Well, we have to do some more anti-differentiation because we haven't done anything complicated. What do you do when there's a composite function? And there is no chain rule like we had for derivatives, so we're going to do what they call U substitutions. So we have to remember these. So this should be done by now, I would think. What's the antiderivative of x to the n? X to the n plus 1 over n plus 1, what must follow it? Plus c. And some of you don't want to practice that, but practice it, because when you get to the exam, if you don't put the c in, you're going to be in significant trouble. Now this is the log of what? X. Now the thing is, it's really the log of the absolute value of x. Because if this is an antiderivative, I should be able to take the derivative of this and get 1 over x. So let's look at that. What is the derivative of the log of the absolute value of x plus c? What's 1 over the function, which is the absolute value of x, times the derivative of the absolute value of x with respect to x. You do not have to know the derivative of the absolute value, but I know what it is. And if you want to know what it is, it's this. It's the absolute value of x over x. And the derivative of c, of course, is just 0. What happens to the absolute values? They cancel, and I get 1 over x. So when you find the antiderivative of 1 over x, you must have the log of the absolute value of x. And you'll see it when we get into the last part of this chapter, which is section 6.4, which is going to be on solving more differential equations, more complicated differential equations, and exponential growth and decay. Okay, you guys remember this one? Cole, do you remember this one? Tangent of x plus c. What about the antiderivative of the sine? Well, let's see. It's cosine of x. This is what I do. Cosine of x plus c, and then I check. Derivative of cosine is negative. I don't have a negative, so I better put 1 in there. You can multiply and divide by constants, not a problem. What's this one? Sine of x plus c. Now, if you haven't done your blue sheet, we're going to take time right now to do this. And there are some of these we can't do. All of our antiderivatives must look like my function I have at the bottom of this sheet. Says function and integral. These are the only ones I know how to do. So if it doesn't look like those, we're going to have to do some work to make our function look like one of these. And we're going to do a substitution. It's called a U substitution. And you'll see. Now, when I first start doing the U substitutions, it might be a little confusing, but ask. But as we go through it, when you walk out of here, you should have a good feel for, what to do with these U substitutions. So I'm going to have you fill that out if you haven't. If you have and you want to try it again, I've got some extra copies right there. So it's not on your sheet, but I have it on my board. Find the antiderivatives. We're doing the bottom part of it. And I have the answers there. Well, almost all the answers. Now, the ones you don't have to know are these guys. Tangent and cotangent. That is not on the exam. I do have to actually do a U substitution to show you that this is negative log of the absolute value of the cosine of x. And since that one's negative, I'm going to guess the cotangent is positive. And it's the log of the absolute value of the sine of x. I'm just looking at patterns to make a good guess as to what it is. I know the first one because I've run into it many times. So go ahead. I'm going to pause my recording and have you guys write down what those antiderivatives are. And some people are done. Do you want to practice again, or do you know what they are? I'm not going to give you a to the x. The derivative of a to the x is times the natural log of a. So to undo it, we have to divide by the natural log of a. This is how I remember it. The derivative of a to the x is a to the x times the natural log of a. So the opposite, which is an integral, would be dividing by the natural log of a. That's just how I remember it. What about, and cosecant squared I think was in there already, wasn't it? This is a repeat, isn't it? What's the integral of cosecant squared? Negative cotangent squared. What about, and secant tangent is, I've already got it up there, it's the secant of x. Okay, the two that aren't there are right here. Is there anything else that's not there? What's this one? Inverse sine. There's really only two you have to know. That one, I should put my plus c's in there though. And what about this one? Inverse tangent. The thing is, you have to have these memorized because you need to recognize it when it occurs in the problem. And you'll see that today. Now, I apologize, you do not have a handout for this next sheet we're going to do, so you're going to need to use just another piece of paper when I get there. This is a summary of everything we've done. We just did it on the blue sheet, that's all. So we really don't really need that, but it's there in front of you. So we're going to do this one. We're going to skip the openers. This is what we're going to do, a separate sheet of paper. What I will tell you is go ahead and divide that out. We've seen this problem before. And expand that one. There is no other way to do those two problems. And I don't like it like that. It's yellow paper because it's hard to see. So here's number one. It's the antiderivative of x squared minus 4 to the third power times 2x dx. And I'm going to go through this slowly. And the reason why I like to do these problems is because they're easier than the ones that are on your handout. And I don't know why we don't have this on a handout. If we do, I'm not sure where they are. That doesn't look like any of the ones on my blue sheet. They have to be exactly like the ones at the bottom of the blue sheet. So what I'm going to do is make a substitution. And you guys have all gone to restaurants and you say, your choice is a baked potato. And you're going to say, I don't want a baked potato, I want French fries. So you say to the server, can I substitute? I'll substitute French fries for the baked potato. It's the same thing. I'm going to substitute. Unless you're on a diet, then you might want salad. Whatever, but you want to substitute. I want this to look like something on that blue sheet. If I didn't have all this stuff in here, this looks like something to the third power, and if I didn't have that. Now, we are going to be particular about the differential being there, because it really makes a difference. These have to match. What's the antiderivative of u cubed? 4 over 4 plus c. Well, I'm going to do a substitution and try to make this look like that. And now I really do have to be careful of all these little things, the differential in particular. So I'm going to say that, let's call this u. Then I have this, u to the third times 2x dx. And guess what? Those variables don't match. So Matt, that's a problem, isn't it? Is that a problem, Julian? Sure it is. These have to match. You can't have mixed variables in there. They are all dummy variables, but they still have to match throughout the problem. So now, since I let u equal x squared minus 4, not to the third, but just x squared minus 4, I'm going to take the derivative of that with respect to x. I got to get rid of this 2x and dx. So du over dx, this is where I'm going to do my substitution. I already did one. What's the derivative of this? 2x. And if I solve for du, what's du equal to? It's equal to 2x times dx. Remember when we did those differentials? You didn't like them. And I did them as du over dx, and we multiplied through by dx to both sides. That's how we did that. So what I'm going to do is now replace 2x dx, because this is an equation. These are equal. That's your baked potato, there's your salad. They're going to replace it. So this is going to become what? Just du. So I'm going to get this. I'm going to get the integral of u cubed, because u was x squared minus 4, replacing that with u to the third power, and 2x dx is the same as du. I did all the math right. I think I did. And that's equal to u to the fourth over 4 plus c. I'm not done. I need to get back to the original problem. And I've got to go back and look what u was. U was x squared minus 4, and I will substitute that back in. So it's x squared minus 4 to the fourth over 4 plus c. It's how I handle the chain rule. Do you see the chain rule in this function? I have a composite function. I have x squared minus 4, and guess what? I see the derivative of this right there. If I didn't have the 2x there, the only way to do it would be to multiply that out, to cube that. Honestly, I probably wouldn't do it right. I'd get out my CAS calculator and have it do it for me. So if I see a function and its derivative, life is good. You just have to be able to see what it is, and the substitution does that. Right.
But it says
They match now.
You substitute x and
Wait a minute, sorry, I want to look at the page. Say what? This is u, and this is 2x dx.
When we finish the problem,
The u cubed and du.
Yeah, you get the x.
No, because the du and the integral sign together means find the antiderivative of that with respect to u. If this had been a dx, I'd be in trouble. I'd need to know how to do multivariable calculus.
You technically say, find the,
Well, let's do some more problems. And this is only first example, so let's look at this one. And I can see a function, and I can see its derivative. General rule of thumb is I look here, and I take the one with the bigger exponent, and that's usually going to be my u. I'm not going to say it's always that, because it's not. You have to just watch out for it. So if I let u equal, whoops, I don't want integral there, sorry. I let u equal x squared minus 3x plus 2, then this would be the integral of, that would be u to the second power, and then I have this 2x minus 3 dx. I can't have that. I've got to figure out a way to get rid of that. But maybe you recognize something about 2x minus 3 and x squared minus 3x. Now, Matt, I don't want to be doing du dx. I want to go right to differential form because it takes too much time. So du is equal to the derivative of this times dx, if you remember from a long time ago. What's the derivative of this? Look at that. That's the derivative. And guess what? This is the same as this. So can't I just substitute in the du then? They're equal. So this is du, and now I have something I can do. I have this. It's u squared, and that's just plain du. And remembering that this symbol with this means find the antiderivative of u squared. I'm changing this to an easier problem. When I look at the original problem, I don't see the power rule. I see a composite function. And then I'm confused as to what to do. So all I can do are that list on that blue sheet. That's it. I got to make it all look like that. So what's this going to give us when I integrate this? U to the what? Third over plus c. And now I got to go back to u. And so I'm going to go back here. Make sure you get back to the x's. Now on the exam, sometimes they just say, do the u substitution and tell me what you get. They don't do the antiderivative. They'll say, this is equivalent to which one of these, using u's. I think I have seen that almost every year I've looked at a multiple choice problem. But I don't get to see them that often. So it's x squared minus 3x plus 2 cubed over 3 plus c. And I know if I did it right or wrong. How can I find out? Check it by finding the derivative. So let's find the derivative of this. The derivative of this with respect to x is going to give me 3 times x squared minus 3x plus 2 all over 3 times the derivative of the inside function. which is 2x minus 3. Does it match? Thank you. I do forget those. By the way, if this were my problem and asked me to check, which they wouldn't, but let's just pretend they did, and I have this, I would not get the point for the copy error because it's not a copy error, because I actually had to subtract 1. If I wanted to simplify that, and I wrote this down, I didn't have the 2 in there after I have it here, it's still clear I wanted it squared. So you got to be careful of that. Sometimes you can get away with copy error, sometimes you can't. And this one I would not. Is that what I started with? Yeah. That's the derivative. So it's a matter of trying to see it. Now some of you will go right to the answers because you're going to see it right away, what the composite function is. And actually, technically what it is, it's the integral of f prime of g of x times g prime of x. That's equal to f of g of x. If you want to look at it that way. I think it's complicated to look at it that way. If I take the derivative of the right side, I get f prime of g of x right here, times the derivative of the inside function, which is g prime of x. I'll take out my dx. And that's really important to put that differential in because it tells you what your variable is. And if they don't match, you got to do some work. Shall we try another one? Go back here. I should have some room on this sheet. Okay, and I'll just rewrite it so you can read it. This one's a little harder. And on just figuring out what you want u to be, it's really kind of a guessing game. But what I look for is I look for a function, because that looks really complicated. I look for a function inside there, in the composite function, such that I see its derivative or a multiple of its derivative. So if I let u equal 5x squared plus 1, its derivative is 10x. Doesn't even look close to 10x, does it? So what would you like u to be? Instead of 5x squared plus 1. I could do the square root, but then it gets complicated. Let's do that. U is equal to this. Square root is the 1/2 power, right? Then what would its derivative be? It's 1/2 5x squared plus 3x plus 2 to the negative 1/2 times the derivative of this, which is 10x plus, oh, sorry, I copied that wrong. I didn't think that was right. It's 15x squared plus 3. I don't think I see anything as complicated as this up here. I don't see anything with a negative 1/2. So that won't work, will it? You can try it, but it doesn't work. So we'll just get rid of that. I'm just going to leave it, though. So what's another choice? One last choice. There's only one other thing you can be. What about just what's underneath the radical? What about just this? Some of you are going to say, well, its derivative isn't equal to 5x squared plus 1. And you are right. It is not. du is equal to what? 15x squared plus 3 dx. But does anybody see the relationship? There's a relationship here between 5x squared plus 1. Yeah. It's a multiple, isn't it? Now, there's a lot of ways you can do this. And it's up to you how you want to do it. I'm going to factor out a 3. And Artavan, you're right. It's 5x squared plus 1 dx. But you know what? That's 3 of them. I don't have 3 of them, do I? I only have 1 of these. So to undo the multiplying by 3, we'll divide by 3. It's an equation. Just solve for this piece. Now, had that been something like just 5x plus 1, I'd be stuck. I couldn't do it. It's got to match perfectly. It's got to be a multiple of the derivative. If it's not a multiple of the derivative, you probably can't find the antiderivative. Most things you cannot find the antiderivative. Okay, so what have we got here? I'll put that next one on another page. So I've got the integral, and this piece here with dx is the same as 1/3 of du. So I'm going to put the 1/3 here, and I'll put the du here. And this right here is the u, and it's u to the what power? 1/2. And we know how to do that one. So it's 1/3, and it's u to the what? Add 1. 1/2 plus 1 is 1/2 plus 2/2, which is 3/2. And I don't want to divide by 3/2 because that's too hard. So dividing by 3/2 is the same as multiplying by 2/3. Good. Plus C. And if this is multiple choice, you would have to finish this. So 2/3 times 1/3 is 2/9. And then I got to put the u back. What was u? Then I have to go back and find it. There's u. 5x cubed plus 3x plus 2, and it's to the 3/2 power. Then I can take the derivative to see if I did it right. A lot of you don't want to do that, but you really should. So what's the derivative? It's 2/9 times what? 3/2 times this thing, 5x cubed plus 3x plus 2 to the 1/2 power times the derivative of this, which is 15x squared, plus 3. Is that the same thing? What happens to the 2's here? Cancel. The 3 cancels here, 1 and 3. And if I divide the 3 into this last binomial, it's a half off my screen, I'll get exactly what I started with. I'll get 5x squared plus 1. All I'm doing is trying to make it an easier problem. Everything has to look like that sheet. So I'm going to take a picture of this one, maybe. And let's try this one. Now there are 2 answers to this. They look different, but they're exactly the same if I do a trig identity. And I don't even know what the trig identity is. So it doesn't matter to me which way you want to do it. Oh, there's even a third way, now that I think about it. You could do a trig identity to begin with. Caravan? What would you like u to be? Now, I want it to be the most, well, not always the most outer function. What do you think? I see a function there and I see its derivative. There's 2 ways to do it. Both are correct. I want u to be cosine. That's what we did in the second hour. It's fine. Works. So I'm going to let this be my u. So u is equal to the cosine of 3x plus 1. Because I don't see the power rule here. Not yet. So what's du? Careful. Negative sine of 3x plus 1 times 3 times okay, so I'm just going to substitute. Well, I almost have everything. I want the sine of 3x plus 1 dx. So it's this. What don't I want? I don't want the negative 3. So how would I undo that? Divide by negative 3. Some of you may say, well, I just want to solve for dx and I'll substitute in and let things cancel out. You can do that. I think it's more complicated because if you see it this way, it's faster. Okay, so let's go ahead and do the problem. So this is going to be, this is my u. This is not quite du, but it's negative 1/3 of du. And now I can see the power rule. I couldn't see it before. What's the antiderivative of u? U squared over 2 plus c. Let's finish it. It's negative 1/6. And u is cosine of 3x plus 1. Because I did this. What's the antiderivative of u? It's u squared over 2. What's 3 times 2? 6. If you did 3 plus 2 and put 5 in there, you get it wrong. And then I substitute u in, and I made a mistake on purpose right now, because it's supposed to be squared. But I would get the full points because this is simply a copy error, because it's clear that I wanted that squared. You see what I'm saying? Now, if you just go from that to this and don't put the squared in, it's wrong. So your best bet, I don't want you to get too picky in details, but your best bet is to make your intentions clear. Say, I'm going to take the derivative of this, and this is what I get. Then you are eligible for the answer point, even if you don't get the derivative right. But if you don't tell them you're going to take a derivative, they don't know what you're doing. I mean, we really do kind of know what you're doing, but we cannot assume anything. So if it's not clear that you're taking the derivative, we can't get to the points if you make a mistake. And you're in a stressful situation. You'll make silly mistakes. You can take the derivative of that and check to see if it's right. I believe it's right. So, this is the first example. Back to your handout. Why don't you guys try this one? I didn't want to go right to this one because it was harder. It's not bad, but it's not going to be, I see a derivative and it's not quite what I want. I'm going to pause this and I'm going to come around and give you some help. Maybe. And as you do more of these, you'll recognize you can't do some things. If you try to let u equal the cosine of 2x, then du is equal to negative sine of 2x times 2 dx. I don't see the derivative of the cosine in there. So that u substitution doesn't work. It does here, right? What would this be? This would be the integral of, okay, so I've got the sine of 2x and a dx. What goes out in front? Negative 1/2, which I barely have room for. And then this is, because this is du, I'm going to put it over here, and then it's 1 over cosine squared, so it's 1 over u squared. Let me clean that up. I can't even read it. And it's 1 over u squared du. Some of you are going to say, well, it's du over u squared. That's true. It is. These are the same things. That's just arithmetic. Because what's 1 times du? Du. It's the same thing. And I can't do this one. Some of you are going to say it's log. No, this is a log. That's the natural log of the absolute value of u. That's not log. Log has to be 1 over u. 1 over x. That's 1 over u squared. So, this is the power rule. Power rule applies everywhere except when the exponent on u is 1. That's a 2. This is u to the negative 2. So what's this going to give me? What's the antiderivative of this? U to the what? Negative 1 over negative 1. And to simplify that, it's going to be positive 1/2. U to the negative 1 is 1 over U, so 1's 1 over the cosine of 2x. If you don't believe me, take the derivative. I like that problem. I have to remember it for tomorrow. Because when I integrated U to the negative 1, I have a negative sign there. And those are important. I'm glad you guys asked that. It's a different problem. I want you to see the difference. You see, this doesn't work with this U substitution. The only way for this U substitution to work is if I have the derivative of that cosine in the numerator. And I don't. 2 can be done. What's the antiderivative of secant squared? Look at your blue sheet. Tangent. Well, what's the derivative of tangent? Secant squared of 2x times 2. I don't have a 2 there, so what can I do to fix that? You can't divide by the variables, but you certainly can divide by constants, because constants don't affect your derivatives. Check it. Derivative of this is 1/2 times the derivative of tangent, which is secant squared of 2x times 2. I'll put that in front of the C's. Well, that worked. That was tricky. It's a tricky one, especially when you think of this one down here. You see how they're different. I see the cosine here, and I see its derivative in my example 2b. I will fix this handout for next year and put that one in there so you can see that. Okay. The answer to this one is going to be 3/2. The answer to this one is going to be the log. Now, if you want to play with the log, so we're taking a quiz on Friday, of the square root of 3 over 2 using log properties. Why don't you try that one? And then tomorrow's a work day. Look at your blue sheet. Is there a tangent secant squared anywhere on there in the derivative? No, so I'm going to think, okay, let's do a U substitution. I can look at a function there and I see its derivative. What do you want U to be? Cole says he wants U to be tangent. It's a guess and check type thing. What's du? Secant squared of x. If I let u equal the secant of x, there may be more than one way to do this. Then what's du? Secant of x times what? Tangent of x. I can do this 2 ways. To do this one, now you've got to be careful here. I'm not going to put the numbers in there, the 0 and the pi over 3. Okay, Julian, are those u's or are those x's? These guys. They're x's. When I switch over to u, I can't put those numbers in there because that would be wrong. I want x's. I want them to be u's. I don't have that. So if I do this, this is u, and then this is du. And if we integrate this, I get u squared over what? 2. No c's, because this is a definite integral. Then switch back to the x's. On Friday, I'll show you another way to do this. You got enough just to do this today. So u was tangent of x. So it's tangent of x squared over 2 evaluated at 0 and pi over 3. What's the angle pi over 3? 60. So if you do your little triangle, I'm not going to draw it to scale. If this is 60, then this is 30. So if this is 2, this side is 1, and this is square root of 3. Okay, art of n, we got to remember this. Remember 30, 60, 90s? If they expect you would do this without a calculator, they're always going to give you this. It's always going to be 30, 60, 90s or 45, 45, 90s. So what is the tangent of pi over 3? Square root of 3. So it's the square root of 3 squared over 2 minus the tangent of 0, which turns out to be 0. Don't assume that whatever that 0 is going to give you 0. It's not true. So it's 3/2. Does this way work? I think it does. Let me rewrite this. This is, I'm just going to get rid of the 0 and pi over 3 right now. I have a tangent of x times the secant of x times the secant of x dx. Okay, this here, that part right there, I better change the red. Secant times tangent and the dx, all of this together is what? That's du. What's the secant of x? It's u. So it's the integral of u du, which is u squared over 2. And what was u? U was the secant of x. And that's squared. And I'm going to evaluate this at 0 and pi over 3. Secant of 0 is not 0. Why is this doing this? Okay, so I'm going to have to figure out what? The secant of pi over 3 minus the secant of 0 over 2. Okay, what's the secant of pi over 3? Secant of pi over 3 is 1 over the cosine of pi over 3. Okay, I'm going to draw my triangle again, because it's just as easy for me to do that. This is 60, this is 30, this is 2, 1, square root of 3. Yes, you should be that fast. What's the cosine of this angle? Cosine is 1/2. So what's the secant? It's 2, right? So this is 2 squared. You're saying this isn't going to work. Watch. Minus, what's the secant of 0? You guys, what is the secant?
1.
Secant of 0 is 1 over the cosine of 0. That's right. It's 1. What's 4s minus 1/2? 3s. It works either way. It's kind of cool. No, not kind of cool. It is cool.